Hi everyone, I'm Mr. Fullerton, and today I'd like to talk to you about electric charges. Our objective today is going to be to calculate the charge on an object. And to begin with, we need to talk about atoms. Matter is made up of atoms, and for many years people thought atoms were the smallest particle of matter possible. We have since learned that that's not true. We can break up atoms into smaller pieces known as protons, electrons, and neutrons. Now, protons and neutrons reside in the nucleus, in the very center of an atom, and electrons orbit the outside of the atom in what we call energy levels. As an electron gains energy, it can move to a higher energy level, and when it falls to a lower energy level, it gives off energy. Now, in the nucleus, protons have a positive charge, neutrons have zero charge, and the electrons that orbit the atom have a negative charge. Most atoms are electrically neutral. That means they have the same number of protons in the nucleus with positive charges as they have electrons orbiting the atom. If the number of protons and electrons are equal, since they each have the same amount of charge, the protons are just positive, the electrons are negative, it cancels out, you get a net charge of zero. That's a standard atom. If you happen to gain or lose an electron, though, you have a net negative charge, and that is now known as an ion. If that atom loses some electrons, it loses that negative charge, it's left with a net positive charge, so we call that a positive ion. If instead it gains some electrons, an electron, two electrons, however many, it now has a net negative charge, and we call that a negative ion. Now, charge is quantized. That means it comes in discrete amounts. There is the smallest possible charge you can deal with. The metric unit, or SI unit of charge, is known as a coulomb. We abbreviate that with the capital C. And you need to know a coulomb is an awfully large amount of charge. Typically, we deal with things much smaller than a full coulomb, things like microcoulombs and nanocoulombs. Now, the charge on a single proton or electron has a magnitude of E, lowercase e. We call that an elementary charge. The value for an elementary charge is 1.6 times 10 to the minus 19 coulombs. That's the smallest possible charge we can have on an electron or a proton. It doesn't get any smaller than that. You can't have half an elementary charge. You can have one elementary charge, you can have two, you can have three. You can't have 2.5. It has to come in discrete amounts of E. And to give you an idea how big a coulomb is, there are 6.25 times 10 to the 18th elementary charges in a single coulomb. Now, the symbol for charge is Q. So if we were talking about the charge on some object, we could say the charge is equal to